define that domain, range and codomain. Then we will learn the function, what is function, alias real function by graphs. So let's start our class. Hi student, welcome back to our channel AnganaStudyCenter. In previous session we have discussed about the relation Cartesian product, domain, range and codomain, and we have done the exercise of NCERT book 2.1. Today we will discuss about some example of relations and define that domain, range and codomain. Then we will learn the function, what is function, alias real function by graphs. So let's start our class. Now look at this question. Here two sets has been given. There is function between the first element and the element of with the element of p and with the element of q. Here we see the question is write the relation between p and q in set builder form and roster form, and what is the domain, range and codomain. So here this is the p set and this is the q set. So now in set builder form, let R be the relation. Okay, so R can be defined as R equal to xy psi that. Here this is x, okay, and this is y. So look at this. Here from 9 to 3 and 9 to minus 3. So here we get the square of 3 and minus 3 will be 9. And just look, 2 and minus 2 will be 4. 5 and minus 5 will be 25. So here we can write x is the square of y. Okay. Then x belong to p and y belong to q. So our set builder form has been completed. This is 1 and now 2. In roster form we can write this as R equal to x equal to 9, y equal to 3. Okay, then x equal to 9, y equal to minus 3. Okay, this complete. Then 4 to 4 minus 2. Okay, then 25 5 and 25 minus 5. Okay, so our set builder form and roster form has been completed. Now here is the question, domain. What is the domain? We have seen in the relation the set of all the first elements. Set of all the first element in relation will be the domain. So domain is four, 9 and 25. Okay. Now the range will be the set of all the second element of the ordered pair in relation. So range will be equal to 3. Here from the lower point we have to write minus 2, minus 3, minus 5, then 2, 3 and 5. Okay. This is our answer. Now there will be another thing, codomain. We know the codomain is the set of all the elements in Q. That means the second set. So the codomain is equal to set 5, 3, 2, 1, minus 2, minus 3 and minus 5. Okay, that means the set Q. Okay, one point should be noted that if two non-empty set A and B, two non-empty set, okay, let NA means the elements in A equal to small p and NB equal to small q, then the subset in A Cartesian product B is equal to 2 to the power p dot q. Okay, then the number of subsets in A cross B equal to 2 to the power P dot Q, and the possible, this number also be the possible number of relation in A cross B. Okay, this is vital. Now in previous lesson we have a question number 8. Okay, in question number 8 in exercise 2.1, there we have A equal to 1 2 and B equal to 3 4. There is a question, how many subsets in A cross B? The answer will be 2 to the power, here A has 2 elements and B has 2 elements, so 2.2 equal to 2 to the power 4. Okay, now we are going to do the exercise number 2.2 from your NCERT textbook. Okay, exercise 2.2. Okay, look at this question. A equal to 1 to 3 up to 14. Define a relation R from A to A by R equal to xy such that 3x minus y equal to 0 where xy belong to n, because n means natural number. Write down the domain, codomain and range. So now solve this equation. We first solve this equation. Okay, 3x minus y equal to 0. So just write 3x minus y equal to 0, where we have to write this as y equal to 3x. Now putting the value of x, we get y. If we put x equal to 1, x equal to 1, because there is from 1 to 14. Okay, then y equal to 3, x equal to 1, then y equal to 3. If x equal to 2, y equal, x equal to 3, y equal to 9, y equal to 4, x equal to 4, y equal to 12. Okay, then if we write x equal to 5, we get y equal to 15, but 15 is not present in the set A, so this is will not appear here. Okay, so up to x value will be up to 4 and the value of y up to 12. Okay, so then R can be write as x equal to 1, y equal to 3, x equal to 2, y equal to 6, x equal to 3, y equal to 9, and x equal to 4, y equal to 12. Okay, this is the roster form of this relation. Now the domain will be set of all the first element in ordered pair of this relation. So 1, 2, 3 and 4. Okay, then range. What will be the range? The set of all the second element of the ordered pair in the relation. So 3, 6, 9 and 12. 3, 6, 9 and 12. Okay, now codomain. Codomain will be the set 1, 2, 3 up to 14. Why? Because we have previously seen that the set B means there is a relation between A to B. Here the relation is A to A. All the members, where we can get this range from the codomain. Okay, just look at this diagram. Here A to A, here 1, 2, 3 up to 14, and there is also image 1, 2, 3, 4 up to 14. Here image only 1, 2, 3. Okay, 2 to 6, suppose 3 to 9 and 4 to 12. Okay, so in this range, the range has been obtained from this set, So all the element in this set will be the codomain. So this will be A. Okay. Here, look at this question. Define a relation R on set N. N means the set of all natural number by R equal to xy such that y equal to x plus 5. X is a natural number less than 4. So x should be 1 to 3 and xy belong to N. Write down the relation in roster form and write down the domain and range. So we have to first solve this equation. Here y equal to x plus 5. So if we put x equal to 1, we get 6. Okay. If x equal to 2, we get 7. If x equal to 3, we get 8. Okay. Here said x is less than 4. So up to 3 we can take. Okay. So in set builder form, the relation R written as 1, 6, 2, 7 and 3, 8. Okay. Then domain will be the set of all the first element in order pair in the relation. So 1, 2, 3. Okay. Then range will be all the second element. That means 6, 7 and 8. Okay. Just look at this question. A equal to 1, 2, 3, 5, B equal to 4, 6, 9. Define a relation R from A to B by R equal to xy such that the difference between x and y is odd. X belong to A, y belong to B. Write R in roster form. So just look. Here the difference between x and y will be the odd. So we just imagine the Cartesian product of A and B. Okay. There should be a pair 1 to 1 and 4. So if we difference that, just like 4 minus 1 equal to 3, this is odd number. 1 and 6, 6 minus 1 equal to 5, this is odd number. 9 minus 1, 8, this is not odd number, so this cannot be written. 2 to 4, this is not odd. 2 to 6, 6 minus 2, 4, not odd. 9 minus 2, so this is 7, odd number. 3, so now we have to write 4 minus 3 equal to 1, this is odd. 3 to 6, 6 minus 3 equal to 3, this is also odd. 9 minus 3, 6 or not odd. Then 5 minus 4, 1, this is odd. 5 minus 6, that means 6 minus 5 equal to 1, this is also odd. And 9 minus 5, this is not odd. So we get this type of pair 1, 2, 3, 4, 5 and 6, 7. So R can be written as R equal to, so first 1 and 4, we get 1 and 4, 1, 4. Okay. Then second 6, 1 and 6, so 1 and 6. Okay. Then 2 and 9, 2 and 9. Okay. Then 3 and 4, 3 and 4. Okay. Then 3 and 6, 3 and 6. Okay. Then 5 and 4, 5 and 4. Okay. Then 6 and 5 and 6. Okay. This is your answer. Just look at this picture. Here two sets has been given in arrow diagram. Okay. There write the relation between the set P and Q in set builder form, roster form, and what will be the domain and range. Okay. This type of example we have done in exercise. Okay. Then look at this question. Here A is a set. Let R be the relation on A defined by AB such that AB belong to A. B is exactly divisible by A. So here the element B will be divisible by A. Okay. Then write down the R in roster form, find the domain of R and find the range of R. So just look. Here we have A cross A. Okay. So there will be 1, 2, 3, 4, 5, 4 and 6. Okay. And we have 1, 2, 3, 4 and 6. Okay, so this is the element, this is the set from which B will be obtained, and this is the set from which A will be obtained. So from this set A will be obtained and from this B will be obtained. So here just look, if we divide 1 by 1, so B equal to 1 and A equal to 1, so this can be divisible. So in R we can write this as 1 comma 1, B is 1 and A is 1. Okay, now second, B is 2, A is 1, this is also possible. B is 2, A is 1, so 1 and 2. Okay, then B is 3, A is 1, this is also possible. 1, 3. So all the element divisible by 1, so these all the element possible 1 and 6. Okay, now from 2, from this element, which is the multiple of 2? So 2 is the multiple of 2. So if B equal to 2, then A will be 2. Okay, so this can be 2 comma 2. Then the multiple of 2 will be 4. So 2 comma 4. Okay, then 6 will be the multiple of 2. So 2 comma 6. Okay, then we have 3. Then 3 is multiple of 3. So we get 3 comma 3. Then 6 is multiple of 3. So 3 comma 6. Okay, now we have 4. 4 is multiple of 4. So 4 is the element. Then 4 6 is not eligible. Okay, now we have 6 and 6. 6 is the multiple of 6. So we have 6 comma 6. So this is the roster form. Okay, now second, find the domain of R. Domain means all the first element, set of all first element in of the ordered pair in relation R. So here 1 exists, 2 exists, 3 exists, 4 exists and 6 exists. Now 3, the range. What will be the range? Set of all the second element in the ordered pair in relation R. So the second element will be 1, 2, 3, 4 and 6. Okay, so just look here, domain and range are the same, and if we have another thing, codomain will be the set A. So domain is also A, range is also A, and codomain will be A. So if there is a question saying that write down a relation on a set A where the domain, range and codomain of R is same. So this is your answer. This is an example. Okay, then look at this question. Determine the domain and range of the relation R defined by R equal to x comma x plus 5 such that x belong to 0 to 5, this set. Okay, so how to solve this? This is so much easy. Okay, here x and x plus 5. So in roster form R will be, if we put x equal to 0, then the ordered pair will be 0, here 0, 5, that means 5. Okay, now if we put x equal to 1, okay, then we get 1 plus 5, that means 6. If we put 2, x equal to 2, we get 7. If we put 3, x equal to 3, then we get 8. If we put x equal to 4, then we get 9. If we put x equal to 5, we get 10. Okay, this is the relation. Then the domain will be element the first element of the ordered pair in the relation. So 0, 1, 2, 3, 4 and 5. Okay. Then range, set of all the second element in the ordered pair of the relation. That means 5, 6, 7, 8, 9 and 10. Okay. So just look at this question. Write down the relation R equal to x comma x cube such that x is a prime number less than 10 in roster form. So x is a prime number less than 10. So x will be x equal to 2, 3, 5 and 7. Okay. So the relation can be written as R equal to, if x equal to 2, we get x cube equal to 8, 2 cube. Okay. Then x equal to 3, then 3 cube equal to 27. If x equal to 5, then 5 cube equal to 125. If x equal to 7, then 7 cube equal to 343. This is the relation in roster form. Okay. Then look at this question. A equal to x, y, z, b equal to 1, 2. Find the number of the relation from A to B. We have previously done in note. So this answer will be the number of relation 2 to the power. Here the number of element of A 3 and here the number of element is B is 2. So 2 to the power 6. Okay. Here just look at this question. Let R be the relation on Z. Z means set of all integer. Defined by R equal to A comma B such that AB belong to Z. That means between the set of integer. Then A minus B is an integer. So just imagine set of all integer, there are the minus value and plus value. Okay. So if we subtract two elements, then we get the value that will be the integer. So here the domain means in the relation this will be exist. Okay, this will be exist in relation and A B will be exist in relation. So the domain should be remain from the set of all integer, and also the range will be the set of all integer. Okay, so here domain is equal to set of all integer, that means Z. Okay, and range will be the set of all integer, that means Z. Okay, we are going to learn about the function. This is the most important topic in mathematics. Okay, we can visualize the function as a rule. Okay, let's see the description. What is function? A relation F. Function is also a relation. Okay, if relation F from A to B is said to be a function if every elements of A, okay, if every elements of A has one and only one image in set B. Okay, let A is the non-empty set and this is the B non-empty set. Here A, B, C, three elements are exist. Here D, E, F. Okay, here there is a relation A and D, also relation B and E, and C and F. So there is one and only pre-image of this element in A. This is the image of A. D is the image of A. Okay, there is the one and only one image. That means here A has only one image D, and B has only one image E, and C has only one image A. There is no two image or more than image. So must be one image in function. Okay, then the relation will be called function. One image. This should be remembered. Okay. If there is the image A has two images, that is D and F, then this is not a function. Okay. So to be a function, there is only one image in set B. Okay, clear? F is a function from A to B. Okay, from A to B, and AB belong to F. Okay, then F is equal to B, where B is called the image of, and A is called the pre-image of. Okay, so just look at this diagram. If there is a here, this is the A set, singleton set, and this is the B set, here B. Okay, so this B is the image of A, and A is the image of B, pre-image of B. Okay, so this is the pre-image and this is the image. Okay, clear? This function is denoted by F psi that A to B. Okay, now we are going to look some example here. Let just look at this example. N is the set of all natural number, and the relation R is defined on N such that R equal to xy, y is equal to 2x, xy belong to N. That means xy belong to natural number. What is the domain, codomain, and range? Previously we have done this. Okay, so is the relation is a function. Now just look in this. Here we have y equal to 2x. If we put x equal to 1, natural number. Okay, so when x equal to 1, we get y equal to 2. Then x equal to 2, y equal to 4. X equal to 3, we get y equal to 6. Up to infinity. This is up to infinity. This is the domain. That means x in xy form. The first element is x. This is the value of x. So domain will be set of all natural number. Okay. Then range. This set of all second element in order pair in the relation R. So 2, 4, 6 up to infinity. So set of all even natural number. Okay, and codomain. From this, y belong to n. That means there is also element 1 to up to infinity. Okay. Okay. So in codomain 1, 3, 5, these also include with these. So codomain will be the set of all natural number. Now just look here. Is the relation is a function? Obviously. Just look here. The image of 1 is 2. Then the image of 2 is 4. Image of 3 is 6. Okay. So there is one and only image. So this is a function. Okay. Just look at this. Here is the question is, examine the relation is function or not. So look at this first. Here, if I draw this diagram, then here 2, 3 and 4 in domain, and there is 1 and 2. So from 2 to 1 and 3 to 1 and 4 to 2. Okay, so there is not only one image. Okay, so here is the image of 2 and 3 is 1. So this is not a function. Okay. Second, 2 2, 2 4, 3 3 and 4 4. So here also 2 2, the image of 2 is 2 and the image of 2 is 4. So there is more than one image. Okay, so this is also not a function. Now question number 3. Here look, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. So there is a one and only image. Okay, that means here 1, 2, 3, 4, 5 and 6. Okay, here is 2, 3, 4, 5, 6 and 7. So the image of 1 is 2, the image of 2 is 3, the image of 3 is 4, the image of 4 is 5, the image of 5 is 6 and the image of 6 is 7. So there is one and only one image. Okay, so this is function. We now learn about the real function. What is the real function? Okay, in real valued function there is a range is the R. Range is the R, or the subset of R is its range, the range of the function. Then the function is called real valued function. Okay, so in this function the domain will be R, that means set of all real number, and range will be the R. Okay, then the function is called real function. Okay, look in the example. Then look at this question. Let n be the set of all natural number. Okay, then define a real valued function f such that n to n by fx equal to 2x plus 1. By the definition, complete the table below. Here fx means y. Okay, in relation we see that y is equal to 2x, y equal to 3x plus 1, y equal to x square plus 1. Here this y can be represented as fx. Okay, so here fx equal to 2x plus 1. Then if x equal to 1, just put the value of x in this equation. We get, if x equal to 1, then we get 2 plus 1 equal to 3. Okay, then y equal to 3. That means fx equal to 3. Then so this is f1, the value of f1. Okay, then fx, if we put x equal to 2, then we get f2 equal to 5. Okay, then f3, if we put x equal to 3, then fx will be f3. Then the value of f3 equal to 7. Okay, if we put fx in x, we put x equal to 4, then we get y equal to 9. Okay, then f5, just put 5 in place of x, then we get f5 equal to 11, and so much. This is your homework. Okay, we are going to learn about the identity function. Let f is the function such that R to R. Okay, f is a function from R to R denoted by y is equal to fx equal to x for all x belong to R. Then this function is called identity function. Okay, so just look here, x and y both are belong to R. So the domain and range both are belong to R. Okay, so now by graph here x dash, y and y dash. This is the origin. 1, 2, 3, 4, 5, 6, 7. This is the plus point. 1, 2, 3, 4, 5, 6, 7. And this is the minus point. 3, 4, 5 and 6. Minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. This is the plus point of y. 1, 2, 3, 4, 5 and 6. This is the minus point. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay. So by this equation y is equal to x. Okay. So x, y both are belong to R. If we put x equal to 0, we get y equal to 0. X equal to 1, we get y equal to 1. So we get 0, 0. So the coordinates in two different. So the point will be here. Then 1, 1. 1 and 1. This is the point. Then 2, 2. Then this is. If we put minus 1, this also minus 1. So then this point will be that. And minus 2, minus 2. This point will be that. So if we draw a line, if we join this point, we get a straight line passing through the origin. Okay. If you have this type of function, then the graph will be this type. Okay. Now, what is constant function? If a function f either R to R, okay, by y is equal to fx equal to c, where x belong to R, okay, and c is the constant, then by this equation we get y equal to c. We put y equal to 0, then we get c. Then we put y equal to 1, then we get c. So here look, here the domain will be R and range will be within bracket c. So now look the graph of this equation or function. Then this is x, this is x dash, y, y dash. So this is the origin. 1, 2, 3, 4, 5, 6. This is the minus portion of y. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Minus portion of x. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5, 6. This is the plus portion y. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. It have minus 1, minus 2, minus 3, minus 4, minus 5 and minus 6. So here we get y equal to c. Okay. Then the equation, there will be a that y equal to c, that means x equal to 0. X equal to 0, that means x axis, and y equal to c, that means let's assume c is in this position. Then this will be the straight line parallel to the axis x axis. The straight line will be parallel to x axis. Okay, the graph will be this type. Now we are going to learn about the polynomial function. What is the polynomial function? Let a function f psi that R to R is said to be the polynomial function for each x belong to R, y equal to fx equal to a0, a1 x to the power 1 plus a2 x square plus dot 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 an x to the power n, where n is a non-negative integer. Okay, and a0 dot 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 an up to an belong to R. Okay, if here look at this, here this is a variable and this is the coefficient, okay, of the variable. So if this type of function exists, this function is called polynomial function. So we have some example, that is, let fx is equal to x square minus 2x plus 2. This is a polynomial function. And let gx is a function where gx equal to x to the power 4 minus root 2x. Okay, this is also a polynomial function. Let a function fx equal to x to the power 2 plus 2x. This is a function given. Okay, and there is a question, is this a polynomial function? What will be the answer? This is not a polynomial function. Why? This is not a polynomial function. Why? We have found from the definition there is the variable and the coefficient. Okay, and the power of the variable will be the non-negative integer. But here, just look, the power of x, that means the power of the variable is 2/3. This is not a integer, not a integer. Okay, this is fraction. So this is not a polynomial function. Okay, that's all for today's class. Next day we will learn about more real function and their graphs, and then we will exercise the miscellaneous problems and the exercise of your NCERT textbook. Before that, just practice all of the class and revise that very well. Thanks for watching our video.